Hi, this is a demo on project given by Exposys Data Labs. So in the given data set, R&D spend, administration cost and marketing spend of 50 companies are given along with the profit earned. The target is to prepare an ML model which can predict the profit value of a company if the value of its R&D spend, administration cost and marketing spend are given. So basically here my aim is to construct different regression algorithms and do the common stuff like divide the data into train and test nets and calculate the different regression metrics and choose the best model. So here I am going to show my implementation, my way of code, how I have done the coding to build a better model which can predict the profit of a startup company when given the input of administration cost, marketing spend and R&D spend. So basically the first thing first, we have to import the libraries that are required. So I have imported NumPy and Pandas for data analysis and data pre-processing, and Matplotlib for data visualization, basically for plotting the graphs, and Seaborn for also plotting the graphs. And finally I have imported the warnings to actually ignore the warnings which I get when I print anything. So this is just to get a clear output without any warnings. So after that, after importing the required libraries, we have to load the data. So to read the data file, I have used pandas.readcsv function to load the 50 startups.csv data that was given. So after loading the data, so basically the steps are data collection, data cleaning and data pre-processing, and after that model building, and after that model evaluation. These are the basic steps that I have followed in my code. So after loading the data, I mean after collecting the data, the next step is understanding the data. So to understand the data, we have to know like how many entries we have in our data, how many columns we have in our data, and what type of columns we have. So all this stuff. So basically here I'm just printing data.shape to see how many rows and columns that I have. So basically we can clearly see here 50 rows and 4 columns this data set contains, and here just data.head gives the first 5 rows of the data. So here clearly we can see all the column names and how many independent variables we have and how many dependent variables we have. So basically in this data we can clearly see these three are independent variables: R&D spend, administration and marketing spend, because these are the input that we have to give to the model so that it can predict the profit. So here our profit is the outcome variable, that is dependent variable, which is being dependent on these three input variables. So here we can clearly see this, all these variables are in numerical form. Neither of the variable is in categorical form. So it makes our job very easy because already we have all the variables in numerical form itself, so that model can process directly. And after understanding the data, the thing we have to do is exploratory data analysis, which is nothing but analyzing the data very well and drawing some valuable insights from it, so that we can prepare the data where we can train the model with this prepared data so that it can actually train well and therefore generalize well on any other input. So basically the first thing we have to do is checking the null values in our dataset, whether our dataset contains any missing values or not. So to do that, we is simply using data.isNull.sum function. So it gives us clearly, we can see here each variable in our data has 0 missing values, means there are no null values in our dataset itself. So our dataset is well provided without any missing values. And the next thing I am doing is checking the duplicates. Here duplicates is nothing but the repetitive entries, the having the same number of numeric entries which are repeating. So we can also clearly see that there are 0 duplicates in our dataset. To do that, I have used data.duplicated.sum. And after that, data.describe, which is basically gives us the descriptive statistics of the data. Here descriptive statistics are nothing but the mean, median, minimum value and maximum value of that particular variable. So for example, when we are considering R&D spend, we can see the count gives us total number of entries this variable have, and what is the mean, the average value of all the entries in that variable, and the standard deviation, and what's the minimum value in that variable, and what's the maximum value in that variable. So basically we can actually get a better understanding of data at hand with this descriptive statistics of data, so that we can found whether there are any anomalies or outliers, so which are those data points very far away from the actual data points. So from this descriptive statistics, we can clearly see that our data is actually very well distributed, and there are not many much anomalies or outliers. Because however, in further steps, we are going to feature scale this data so that every variable and every quant variables that are present here will be normalized, and everything lies in usual range, in the same range. So the magnitude, there is not much big difference in magnitude. So after that, the data.info gives the information about data, like how many non-null objects each variable have and how much memory usage it takes. Here we can clearly see it takes 1.7 KB. That's it. It depends upon the system and the data type of each variable and all. So this is common stuff. And here what I'm doing is I'm checking the correlation of each variables. Means here I'm just checking the correlation of my independent variables with my dependent variable, like how correlated they are with the dependent variable, each independent variable. So here we can clearly see marketing spend independent variables is the correlation between this marketing spend independent variable and the profit dependent variable is coming to be 74.77%, means it is actually correlated with it. And here we can see the R&D spend also, the correlation with the profit variable is 97.29, means it's very highly correlated. And here also we can see some 20.07%, this means also it is correlated with this profit variable. So we can clearly understand that each independent variable in our data is actually correlated with the profit variable. So we can clearly decide that no variable cannot be removed from the data. We have to train the models with each and every input variable that we have. So after here we can have a plot, data.correlation gives the correlation matrix of the data. Means clearly we can here see the correlation between each and every variables. Means we can see the correlation between independent and other independent variables also, as seen here. And here I plotted this heat map, which makes the correlation matrix look more elegant and beautiful with colors and some labels. You can clearly view this here. So after that, here this SNS.pair plot of data gives the, this is just for visualizing the data that we have. So like here there are multiple bar graphs and scatter plots, so we can actually get a better understanding of data visually here. So this is for visual understanding of our data. So after that, here I'm plotting a dist plot of our profit variable to check that whether it is linear or not. We can clearly see that it is linearly distributed, so there is no need of further pre-processing because our data is well provided for us. So there is no need of more complicated data pre-processing. We can directly feature scale the variables that we have. So here feature scaling, I am using standard scaler. The standard scaler simply normalizes the independent variables, and you can clearly view the quant here. So this xtrain is nothing but uh, the training part of independent variable after feature scaling. So you can see this array here. This is after feature scaling. So basically we are feature scaling only the independent variables, so dependent variable need not be feature scaled. So basically we are dividing the data into dependent and independent variables. So dependent variable is given to y and independent variables are given to x. So these independent variables are feature scale, and after that we are performing train test splitting. So we can in train test splitting, I'm just using the function that's already available in sklearn module. So here I'm just giving 15% to testing phase and 85% to training phase, so that it can train well and therefore test well. So after train test splitting, the final phase is model building. To build the model, we have to import the models that are present in sklearn module. So here I have imported different models. So linear models like linear regression, ridge lasso, and tree based models like decision tree regressor, and ensembling models like random forest regression, gradient boosting regressor, ADA boost regressor, extra tree regressor, and some more models like SVR, k-numbers regressor, and XGB regressor. So these are some models that I'm going to train and test. So finally I'll be choosing the best models out of these. So for metrics, for evaluation, I'm using these metrics such as mean absolute error, mean squared error, and R2 square error, R2 square, which is an adjusted R square. These are the common metrics that are used in regression algorithms. So here I'm just initializing the models. I'm creating objects for each model here, and after that Let me explain this phase. Basically, we know we have to fit, means train each and every model and therefore test. So instead of doing for every model manually, we can actually create a function which can take each and every model at a time and can directly train and therefore test well without any manual repetitions. So here I have created a function train regressor which can take the model and the xtrain ytrain and xtest ytest as inputs, and basically it trains the model which has given as input with xtrain and ytrain. So after training, it predicts the xtest values will get that will be stored in ypred, and after that we'll be just calculating the scores r2 square and mean absolute error and mean squared error using this ytest and ypred that we get from that particular model, and after that we are returning those. So here this dictionary is for storing each model with some specific names, so that here in this phase I can call those models from the classifier and I can give it to the train regressor, so that it can at a time take all these models one by one and can just perform training and testing and directly print the scores here. So here I am those written metrics are stored in current R2, current ME and current MSE, and finally printed here. You can view here. So for each model we can see the R2 square, MAE and MSE, and out of all these we can clearly see that logistic linear regression. So linear regression is performing very well here. 97.95% of R2 score and 5265 of MAE, 4921067 of MSE, which is basically best compared to all these models. So after choosing the best model, we have to improve that model further. So in order to do that, here I have done a method which is similar to k-cross validation. Basically, while we are training the model, we are giving some random state. This random state is nothing but it chooses the certain random sample of data to split into train and test. So for certain train and test, we can get a very good model. So in order to do that, I am creating an empty list scores, and I am just train test splitting for every random state until 1000 iterations, and I'm creating a linear regression model in every phase, and basically training and testing for every phase, and storing the scores of all these linear regression models in the scores list. So finally here my idea is to get the best score and where the best score is occurring in which random state, so that I can particularly put that random state and just train and test the model. So after getting the max, here I can get the index where the maximum score is. So 815 is the index where the maximum testing score is occurring. So I simply put random state is equals to 815 and simply trained and tested using linear regression, and finally able to achieve a 99.7% of testing score, so which is pretty good. Actually it's almost 100. But actually here when we see the training score, it is 93.7%. So and the testing is 99.7. we can see there is a difference like almost 5 to 6. So actually here itself it's a very good model, but to make it even more better model, to reduce the overfitting, to make it zero overfitting, I am just again calling the empty scores list, and here for each iteration I am storing the scores where it takes the difference of train scores and test scores, absolutes of train scores and test scores, because my idea is to I can get the minimum from here and I can know the index where the difference of training and testing scores is so less. So I found that 915 is the random state and I have put there, and again I have calculated the scores after training and testing, and here I can clearly see that training accuracy, training score and testing scores are 95. So there is no overfitting at all, and our overall score is above 95% without any overfitting. So this is the best model, best linear regression model that I have developed using this data, and finally I have saved these models. So finally the conclusion is, after following all these steps, I have finally developed a model and I have chosen the best model, and that is linear regression, which is giving above 95% of the score. And the metrics I have used are mean absolute error, mean squared error and adjusted R square, which is R2 square. So the methodology I have followed is data collection, data cleaning and pre-processing, feature scaling, model building and model enhancement. So these are the steps that I have followed and finally build this model, and this is the demo, and thank you so much.